Hi everyone, this video is for section 5.5 right triangle trigonometry. This particular problem is question 12 from page 349 of your textbook, so if you would like to pause the video in order to grab the textbook, a notebook, or some scratch paper to follow along with me, please go ahead and do so. So to begin, the problem reads the angle of elevation to the top of a building in Seattle is found to be 2 degrees from the ground at a distance of 2 miles from the base of the building. Using the information, find the height of the building. So the best approach with problems like these, basically a narrative problem, we want to go ahead and maybe draw out a picture. So I've gone ahead and already done that. And as you can see, I've already added the disclaimer that it is not drawn to scale. I've also taken the opportunity to draw you in to, make this feel really personal. Please don't be alarmed by the amazing likeness that you're seeing in front of you. I'm just really good at drawing. I've also included the side of the building. I figured we didn't need the rest of it because we're just looking for the height. But I have gone ahead and was kind enough to label that that one side is the building and that the top is supposed to be the top of the building. So let's go ahead and actually start putting in the information that we're getting from this word problem. We do know that the distance between you and the building is going to be 2 miles, so I'm going to go ahead and jot that in. I also know that I have a angle of elevation, excuse me. So basically what I'm saying is my angle of elevation is from the bottom and looking upward. And we know that this is 2 degrees. So if we draw in that terminal side, we have, amazingly enough, created a right triangle. It's amazing, right? Take a moment if you need it. So from here, we're going to go ahead and see what information we have and what information we don't have. I do know that my goal is I want to find the height of the building. So I'm just going to use the variable y to represent that. Okay. There's really no reason why I selected y as my variable. I could have easily have used h, for example, if I wanted to. So now let's go ahead and see what information we do have. We have an angle. We have a side that's adjacent to that angle, and we want to find a side that is opposite of the angle. So what I'm thinking is that the best trig function to help us out here would be tangent. Because we know that the tangent of 2 degrees is going to be opposite over adjacent. Okay, so instead of words, let's go ahead and actually put those values and variables in here. So we know that the opposite is going to be our variable y, and our adjacent is going to be the 2 miles. From here, we would need a calculator. So if we use the calculator to evaluate the tangent of 2 degrees, we get 0.034920765. So I'm using the full value that I got on my calculator. And what we have left, we still have y over 2. But now, at this point, our problem has become, I would say, pretty clear as to what steps we need to take at this point. We want to get the variable alone, just as we have been in algebra since the beginning of time. So in order to clear that, we're going to go ahead and we'll multiply both sides by 2. And then the product that you're going to see here on the left-hand side becomes 0.069841539 is equal to y. So, but remember that we're basically saying here that we should include units, essentially is what I'm trying to say as I stumble through my words. This 0.069841539, this is in miles. So we found the height of the building in miles. And I know that this seems relatively small number-wise, but again, including that unit of miles kind of puts things into perspective. So to actually make this a little bit clearer, because again, if you walked up to someone and did you know that this building in Seattle is, about 0.07 miles? People would be kind of like, great, but that doesn't make a whole lot of sense to me. And we usually measure things in like stories or feet or something like that. So let's go ahead and convert this to feet. So I'm going to go ahead and take my answer. And I'm going to do some dimensional analysis in order to convert it to feet. So I know that since I have miles in the numerator in this ratio, I'm going to put miles on the bottom and feet on the top. And I just need to identify the general relationship between feet and miles. 1 mile contains 5,280 feet. So this tells me I'm going to have a building that is approximately 368.76 feet tall. I think at this point people kind of understand that a little bit more if you were to tell them that a building is 368.76 feet as opposed to 0.07 miles. So here's your answer. If you have any questions or would like to leave any feedback, please let me know, and I hope this video was helpful.